Okay. All right, we locked in. You can see what you got. Okay, there we go. What is this called? What is this called right here? Oh, the empirical rule. Okay, I will put this back up there. Okay, here is what we are doing this chapter. Let me rephrase that. Here is what we are doing the rest of the year. Everything that we do is what they're going to call a normal distribution. So when you hear the word normal distribution, that means you are dealing with a perfect bell curve. Everything that we do will be a perfect bell curve. Okay? This is not a perfect bell curve. Okay? I mean, to be a perfect bell curve, it's smooth, it's symmetric. You know, if this was the middle, it's symmetric. This would not be a perfect bell curve because it's not symmetric. If I folded it right here, this does not equal that. What else? This is not a perfect bell curve because it falls below the x-axis. This is a perfect bell curve, okay? So everything that we do is a perfect bell curve. Hence, a normal distribution. That's what they mean by that, okay? Now, this is what we did in Chapter 2. We introduced you to the empirical rule, okay? Remember how the empirical rule works. The x-bar would go here. 1 standard deviation above, 2 standard deviations above, 3 standard deviations above. And then it goes the opposite direction. -2 standard deviations, -3 standard deviations, etc. Okay? Now you really don't need to know the percentages because this chart that I gave you will give you all the percentages. But we knew that from here to here was 34%, from here to here was 13.35 or 13.5%, and this was 2.35%. Okay? And we knew that 1 standard deviation above and below the mean, like you guys did on your gas project, represents 68%. This represents 95%, and this represents 99.7. Okay? But here's the problem. The empirical rule only works when you have a perfect standard deviation of 1, or a perfect standard deviation of 2, or 3. Well, what happens when we do this and our standard deviation is 1.25? Well, the empirical rule doesn't work now. And if you really think about it, do our standard deviations, whenever we do a calculation, does our standard deviations always come out to be 1, 2, or 3 perfectly? No, they come out to be 1.12, 1.68, -3.42. You know, most of the time you have decimals. So the empirical rule is very limited to what it can give you. On the other hand, what do I do with all my charts? On the other hand, as soon as I find my charts, are they back there? Vanessa, right there?
Yeah.
Okay, I see one. Okay, on the other hand, this, if you take a minute and look at it, look along on this side where it starts at 0.0 to the on the right. Notice how far does it go down to? 3.4. And then notice across the top, it gives you 0, 0, 0, 1, 0, 2, 0, 3, etc. This chart will round to the nearest hundredth. So if you notice at the very bottom, you got 3.4. If I asked you to find 3.40, your answer is 9997. 0.9997. If I asked you to find 3.49, you would go to 3.4 and you'd scroll over to the very end where it says 0.09 at the top. 3.4 plus 0.09 is 3.49. See how that works? And you get 0.9998. Okay? So are we seeing how this works? So the first chart, this column here tells you the nearest tenth, and the number across the top tells you to the hundredth spot. Okay? Now, notice, doesn't this represent 3 standard deviations? So 3.49 would be like right here. Negative 3.49 would be right there. This chart tells you all the answers between 3.49, and negative 3.49. It tells you all of the bell curve. Okay? Now, how do we get these answers? Well, we run formulas for them. But for today, I'm just going to give you the z-score. You just have to look up your answers. That's all you're doing, is you're just learning how to look these up. Okay? So, there are 3 scenarios. This is what you need to really write down. When you're reading a Z chart, there are 3 scenarios that can happen. Okay? So here we go. And then we'll just do a couple examples and we're done. So, we'll just call this to read a Z chart. Number 1. The first scenario is to the left. How to read an answer to the left. Here's an example. Remember on your test, I wanted you to write down all your probabilities like so. You know, let's just put a 1 right there. I wanted you to get in the habit of showing me your probability statement. Like P parentheses X equals 2. P parentheses X is less than 2. This is why, because we have to start doing it all the time now. Let me graph this just real quick so you can get an idea of what I'm talking about. Well, here's 0, this would be 1, this would be 2, and this would be 3, and this would be -1, -2, -3. These values represent like our standard deviations. So think about Z as being our standard deviation at 2.51. If you had to look, wouldn't you kind of guess that like 2.51 is approximately there? And since this is pointing to the left, I'm asking you to find all of this answer for me. If you just had to take a guess, what percent do you think this would be? Like roughly, how much of this graph is shaded? If you had to guess. Like 90, 95, 98, 97. Wouldn't you think like 97% of this graph is shaded? Well, let's go to our chart. This will tell you what percent of your graph is shaded. What is the probability of it? So go to 2.5. So go to 2.5 down the left column, and then go over till you get to 1. So 2.51, what do we get? 2.51. Anybody? I'm holding my finger. What are the 4 numbers that it represents? 0.9940. Okay, so I want to make sure before we go on that you're getting this. So go to 2.5 down the left-hand column, and then scroll over until you get to 01. 2.501, which is 2.51, 9940. So you're telling me this: 99.4% of this graph is shaded. Okay, that makes sense according to my graph, right? It looks like it's about 99% of it's shaded. Okay, that's what this tells you. That's a probability, 99% chance of this happening, because look how much of it's shaded. Okay, what if I did this? P is less than -1.1. Let me rewrite that. Z is less than -1.15. Let me sketch it. You don't have to do this today, and I'm only going to do this for a couple problems, but I want you to kind of get an idea of how this works. -1.15 is right here, approximately. Here's -1, so 1.15. I want this area right there. So by just looking at it, I'm like 20% maybe 15%. It just depends how my scale is. But let's look it up. So go to -1.1, flip it over, and go to -1.15. What do we get? 1251. So you're telling me that there's a 12.5% chance of that happening. Does that it looks a little bit bigger than 12%, but that's what it roughly is. It's about 12% shaded. Any questions? So, do you notice that this chart only gives you the answers to the left? So anytime you have to find answers to the left, you just look it up and you're done. Okay, any questions on how to find answers to the left? Okay, let's go to the right. Here we go. Z greater than, we'll go 3.01. What's up?
Just dropping off your weekly.
Oh, my weekly stuff. Okay, I'm gonna graph it. If our graph only tells you the area to the right, and I want to know this, or excuse me, our charts only tell us the area to the left, I want to know this answer right there. That little teeny piece. Well, look it up. Look up 3.01 on your chart. What do you get? 3.01. Should be at the very bottom, close to the bottom. 3.01. 9987. Does this make sense that the answer is 99%? What should it be? What should you do? Very good. Whenever you're asked to find the area to the right, you always take 1 minus whatever it says. Because your chart, and I'm going to do sideway lines here, when you look up 3.01, it's telling you this. But we want the other side. So we just take 1 minus, just like you did on your test. What is 1 minus 0.9987? I believe, hopefully my math is right, 0.0013. Look at that. You're just telling me like 0.13%. Very small percent of that is shaded. So anything to the left, you look it up. Anything to the right, you take 1 minus. Here's our last one of these. What would be Z greater than 0.25? So here's what I do. As soon as I see that it's a greater than symbol, I immediately write 1 minus. So I don't forget. Anytime I see anything to the right, it's 1 minus. Can somebody tell me what 0.25 is?
0.5.
Point what?
597.
Okay. Now, on your calculators, just take 1 minus 0.5987. Can somebody do that for me real quick? 1 minus 0.5987. So this is the only thing you need a calculator for, is just to get these.
0.4013.
0.4043.
0.4013.
Oh, 13. Okay, there you go. Any questions on how to find area to the right? Here's your last scenario. I'll put it right here. I guess this would be considered the hardest one. Area in the middle. Okay, you're finding area in the middle. Here's what it looks like. Let's go 1.20 less than Z less than 2.12. You're finding the area in the middle. Here's what it looks like as a graph. Here's 0. Here's 1, 2, 3. -1, -2. So 1.2 I would estimate to be right here. 2.12 would be like right here. I just want to know this little piece of right there. I just want to know that little sector. Somebody look up 2.12 for me. What is the value for 2.12? 0.9830. Okay. Can somebody look up 1.20? 0.8849.
Wait, 1.20?
1.20. I can verify it.
Is that not?
1.20 should be 8849. That's
What
right.
am I looking at?
Are you on the positive side or negative?
Oh, I'm a negative.
Okay. And then 2.12, I'll just verify it. 2.12 is 9830. Okay, so let's think about this. When you found 1, 2, you just found all of this. And when you found 1.2, you found all of this. How are you going to find just this area right there? You're going to what? You're going to just subtract them. There you go. When you find the area in the middle, you just take the bigger number minus the smallest number. You just subtract your probabilities. Here is the answer. 0.9830, 0.9830 minus 0.8849, 0.0981. Okay? That's all we're doing today. You're just practicing reading your Z-chart. Okay? Just learning how to find all these different scenarios. Just to give you an idea, here's somebody wanted to say like, well, how is this going to be used? Here's an example, and I'll just read it real quick. Here would be like a word problem that we'll introduce you to tomorrow. A survey indicates that people keep their cell phone on average of 1.5 years before buying a new one. The standard deviation is 0.25 years. A cell phone user is selected at random. Find the probability that the user will keep his or her current phone for less than a year. So what we got to do is we got to run that through a formula. Okay, that's going to give us this Z-score, and then we look it up.
Please release the varsity baseball
Okay,
team
that's what we
along with
do.
the varsity and JV softball teams for the games at Lake City High School.
Lake City,
Yeah.
wasn't it kind of ugly last time?
Yeah.
Is it going to be better?
Hopefully.
All right, okay. That's all I got. So, I had to take a picture.
A picture.
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 Okay, here's our assignment. It is on page, hold it. We did 242. Well, I'll wait till you guys get your book. Do 11 through 16 for me. That is just telling me this. I don't even have to wait till you get your book. Does this represent a perfect bell curve, yes or no? Yes. Does this? Does this? Does this? That's all they do, is they give you a picture and you tell me yes or no. Does that represent a bell curve? Okay. The rest of it is just reading your Z-charts. Here we go. Let's do, and I'm not having you do all of them. Somebody calm me into letting them do some extra credits, so I'll let you do that. Let's do 22 or 23 through 33 odd. Now, I didn't talk about it, but I'm guessing you can figure it out. I like to use symbols, and so does your book most of the time. But on this 23 through 33, they're going to say this: to the left of 2.51. They just put it in words. Find me the left of 2.51, and then look it up, okay? The last section, they give it to you in symbols, 47 through 52. There you go. You're just reading Z-charts. Here's some extra credit. You could do 24 through 32 even. Just practice reading your chart. And then you could do 34 through 36. Get you a few points in that. This adds up, I guess. Okay. One last thing, because I know it's going to come up. Our Z-chart only reads to the nearest hundredth. So if they give you 3 decimals, what do you think you're going to have to do? You're just going to have to round it. You're just going to look up 2.76 when you look it up on your Z-chart, okay? So if they give you 3 decimals or more, just round it to the nearest hundredth and then look it up, okay? When we do it on our calculator starting tomorrow, you'll just set your calculators to 2 decimals. You'll never have to worry about it. All right, there you go. Reading Z-charts. Tomorrow, we start word problems tomorrow. I only typically do 1, because by the time we write it out and do everything and write down the steps, that takes a little bit of chunk of time. So we always do 1 problem to get in your notebook, and then have you go from there. Okay? This next chapter, if we threw out this section, is 3 sections long. All our chapters are short and sweet, which means we typically have a test about every week. Somewhere right around there. Week, a day, a week and a day, a week or 2 days. Somewhere around that area, okay? Answers up here if you like to check your work, okay? There we go. I'm gonna put a grade on your test. If you'd like to come back and see what you got, you can do that. We'll go over it once everybody's got a chance to take it.
What I did.